Lake Superior is a remarkably cold lake compared to small lakes around it, but also Lake Superior is significantly colder than the other Great Lakes. It's actually a lot further north and sits in a much colder climate than the other Great Lakes. The other really important aspect is that it's just really deep. And so in the spring, when things are warming up, you have to warm up that entire bulk of the water, and it just takes a very long time. My name is Jay Austin. I'm a professor at the University of Minnesota Duluth. I work in the Department of Physics and Astronomy, but also here at the Large Lakes Observatory, which is a group of scientists on campus, all committed to developing a better understanding of how large lakes around the world function. Winter conditions play a huge role in determining what happens the following summer, as much as whether we're having a warm or a cold summer. Basically, since about 1980, we've seen a dramatic increase compared to what happened the previous 80 years. The lakes are 4 to 5 degrees Fahrenheit warmer now in the summer than they were 40 years ago. And a lot of that is driven by the fact that we are having much milder winters, which means less ice. And again, those winter conditions end up rolling forward into what happens in the summer. And so it's a combination of milder winters and warmer summers that are causing surface temperatures to be measurably and statistically warmer now than they were 40 years ago.
When you step out on a lake in winter, it's dead quiet. The snow is completely decking the entire lake, and you think, okay, if it's quiet up here, it's got to be quiet down there. As more researchers are finding out in the winter, there's actually a lot going on under the ice. All right, let's see what we got. With time, the amount of ice that's on the Great Lakes and the length of time that ice is out is changing. When it's uncovered by ice and snow, you get a lot of sunlight that regulates where the phytoplankton are in the water column, and that kind of structures this food web. So what we're doing in this winter project is collecting samples from different depths in the water column that will be able to tell us where are those phytoplankton sitting and what types of zooplankton are there. You got some copepods in there, some cladocerans. Lots of interesting questions can be answered using these little creatures. With time, the amount of ice that's on the Great Lakes and the length of time that ice is out is changing. So we're seeing extended ice-free seasons. That could mean big changes in biogeochemical cycling. When the ice is free, when the ice is off and that water is open, how does that change the physics of the lakes? How does that change mixing? That affects all aspects of the lake functioning.